Hello, everybody. Today we are going to start our new one, technical talk in Codeberry Club community, and today we will continue to talk with Vadzim Kavalkou about performance. Hello, Vadim. How are you?
Hi everyone, not so bad, not so bad. And what's going on your side?
Everything, I think, good. let's
It
let's
could
talk
be.
about performance.
Yeah, okay.
So let's start.
Okay, thank you. Hello everyone. Now we'll continue in our journey about the performance regarding the GVM stack. And today we'll take a look on the Quarkus Reactive and compare its performance with Quarkus Reactive as native. And moreover, if you've been visited my previous sessions, we'll compare it with Spring Reactive and Spring Reactive native and Spring Web and Spring Web native. So right now, I'd like to mention that I'll answer your questions in the end of the presentation. And now we are going to start it. Okay, so what about the agenda? First of all, I remind you, if you are a newbie in these sessions regarding the performance, who am I? And I'll introduce myself and bring some business ideas of the application we are going to test. And we'll take a look on the Quarkus Reactive testing results and Quarkus Reactive as native testing results. After that, as I said, previously, we'll compare the Docker performance problems. We'll take a look on it, why the performance on the Docker is pretty less in comparing it with the default one solutions. And sorry for my mistake. Yeah, I understand the 2.6. Yep. And after that, we'll compare the testing results of all the three sessions and sum up. Okay. So who am I? Now I'll present myself, tell about my experience, domains, technical stacks, and social networks. My name is Vadzim Kavalkou, and I'm a chief software engineer with more than 7 years of IT experience. My key business domains are finances, human resources, crowdfunding, and healthcare. I'm a T-shaped person with core knowledge in JVM stack, proven experience with Java, Kotlin, Spring Boot, Spring Native, JIB, Docker, and etc., etc. Moreover, as I mentioned, as a T-shaped, I'm familiar with the Kubernetes, GitHub, GitLab CI, JMeter, and Kotlin performance testing for sure if you're talking about the performance, and Google Cloud Development Architecture. Now you can here find my GitHub stats. They're a bit outdated, but you could visit my GitHub profile, and it's under my avatar. And you can find here the LinkedIn and Instagram links. Okay, so let's talk about one more time about the Reactive Manifesto, Quarkus overview, and Quarkus Reactive, and compare Quarkus with Spring on the high level. Okay, well, what is the Reactive Manifesto? Reactive Manifesto about the responsive, resilient, message-driven, and elastic. So what is responsive? Responsive, it's about the delivering of a consistent quality of service to the users. All systems react quickly and consistently to events happening in the system. What about the resilient? Resilient is about staying responsive in the face of failure with key characteristics. It applies distributed systems. Message-driven is about the asynchronous messaging, and it's about enabling loose coupling of the application components by exchanging asynchronous messages to minimize or isolate the negative effects of resource contention, coherency delays, and inter-service communication network latency. It is the base to support the other reactive characteristics. It also helps for isolation and support location transparency. And what is the elastic? Elastic is about the system staying responsive under varying workload. It can scale up or scale down the resource utilization depending on the load to the system. So, okay, we reviewed the reactive manifesto, so let's talk about the Quarkus let's take an overview of it. So what makes Quarkus different? Kind of developer joy. Yeah, it's really funny, and developers could have a lot of different approaches to build a cloud-native applications quickly and efficiently. What about the quickly? I'm not so sure, but efficiently could be. Kubernetes native. Quarkus was built from the ground up for Kubernetes, making it easy to deploy applications without having to understand all of the complexities of the platform. And it's imperative and reactive. We'll talk about it a bit later. So traditional Java stack were engineered for monolithic applications with long startup time and large memory requirements in a world where the cloud containers and Kubernetes didn't exist. Java frameworks need to evolve to meet the needs of this new world. So Quarkus was created to enable Java developers to create applications for a modern cloud-native world. Quarkus is a Kubernetes native Java framework, as I mentioned, and tailored for Graal VM and Hotspot, crafted from the best-of-breed Java libraries and standards. So the goal is to make Java the leading platform in Kubernetes and serverless environment, while offering developers a framework to address a wider range of distributed application architectures. So what is Quarkus Reactive? In the traditional operative approach, frameworks assign a thread to handle the request. So the whole processing of the request run on this working thread. This model doesn't scale very well. Indeed, to handle multiple concurrent requests, you need multiple requests, and so your application concurrently is constrained by the number of threads. In addition, these threads are blocked as soon as your code interacts with remote services or some other blocking systems, so it leads to inefficient usage of the resources, as you may need more threads, and each thread, as they are mapped to operation system threads, has a cost in terms of memory and CPU, and regarding the context switching and etc. So it's a different thread per request approach. So on the other side, we could take a look at the reactive model, and it relies on non-blocking IOs and different execution model. Non-blocking IO provides an efficient way to deal with concurrent IO. A minimal effort of threads called IO thread can handle many concurrent IOs. With such a model, request processing is not delegated to a worker thread, but uses the IO thread directly. It saves memory and CPU, as there is no need to create worker threads to handle the request. It also improves the concurrency, as it removes the constraint on the number of threads. Finally, it also improves response time, as it reduces the number of thread switches, as I mentioned here. Okay, let's compare on a high level Quarkus and Spring. Quarkus is another framework with a similar approach as Spring, mentioned by Buddha, but with an additional promise of delivering smaller artifacts with fast boot time. We'll compare it. Better resource utilization, for sure. We'll take a look at it as I've mentioned, and efficiency. It's optimized for cloud, serverless, and containerization for containers. But despite this slightly different focus, Quarkus also integrates well with the most popular Java frameworks. And Spring Boot is Java-based framework focusing on enterprise applications. Of course, you could tell me that, hey, Vadzim, Spring Boot 3.0 is going to be released soon, and it will bring us the same approaches that Quarkus leads us. It will be optimized for cloud servers and containers. Yeah, we will have it for sure, but we could compare the performance right now, right here, for this experimental feature in Spring Boot. This is an experimental one. So, okay, what about the business idea? I'll remind you what the application logic, use cases, and database structure we will have. So application, it's a typical transportation service. We are going to move from one point to the other point and book our transfers. and all these cases I'll list you soon. So when I go in our application work from 8 till midnight, I mean the working time of transfers, not the application. 60 hours per day or 112 hours of load per week. And presets, I disabled all caches to get clear metrics. The database and application run in the same network to avoid lags and penalties. Fetching strategy is eager. The average time to put up services doesn't depend on database structure, because if I've already prepared the database and pre-filled it with the data, and we have now need in database migration tools such as Flyway or Liquidbase, and all database structure, as I said, had been prepared. And as the loading tool, I choose Gatlin. It's pretty flexible and easy to join in. To compare it with JMeter, for me, it's as a for developer, pretty comfortable. The versions of a language, frameworks, and libraries in database are latest LTS at the moment of testing. So I'll bring you some information regarding the application. So it's about the country with 6 cities. It's about Belarus. I'm talking not about the that in Belarus there are only 6 cities, not about the major ones. And so in every city we'll have about 20 points to be able to arrive or depart. And I assume that every point will have about 100 transfers. So the target audience is 200,000 users, and every one of them has at least 2 transfers that I pre-filled. About the use cases, I'm going to choose a country, a city, and the origin and the destination. For sure, I'd like to choose a date of transfer. And for all these data, I'd like to select the transfer. It would be nice to book it, to see all my transfers, and to view my transfers that I owned. And I'd like to edit any of my transfers and or cancel it or complete transfer that have been passed. And I'd like to see my profile and update it for sure. And as you can see, we have there are a lot of GET requests, but some of them we can meet the POST and GET and PUT. So it's for about 50-50 about the reading or updating or creating. What about the data structure? Data structure, as I mentioned, country 1, city 6, locations 120, and transfers 12,000, users 200,000, and a half million of user transfers. And pretty easy to answer relationship diagram. And database size is 150 megabytes, and dump a bit easier. Docker image with pre-filled data is 160 megabytes. Let's take a look right now on Quarkus Reactive test results on basic configurations, and we'll analyze Docker images. We could take on our application YAML Quarkus file pretty easy. To use an R2DBC in this approach, we now need to predefine the prefix as R2DBC as in Spring Boot. We could just use the PostgreSQL and then the host, ports, database, and schema, and that's it. We can have a lot of different approaches to build a container image or not a container image. To be honest, Quarkus presented for about 16 or 17 approaches to build your application. Some of them I was not able to build or run, and in these cases I've even visited different sources and contact with Quarkus developers, but I didn't spend for a week to bring the solution in live, and I just skipped it because we are going to bring our solutions in the world as soon as possible, and because of as we know, the time is the money. And what about the basic configuration of my laptop, where I've performed all my tests? It's about the 33 gigabytes RAM, and it's i-Core i7, and GTK 17, garbage collector J1, Gradle 751, and Quarkus 213 1 final. Okay, what about the results? As we can see, we are handling for about 800,000 requests at all. And if you remember, on the previous week, I've presented you the solution of Spring Reactive, and it's handled for about 1,200,000 of requests. And the cure was for about 8%, but right now we can see that there is 13. It's not such a good results in comparison with Spring Reactive, but we will compare it a bit later. And the RPS is 750 counts per second, and the response time of the 95 percentile is about 40 seconds. I would like to remind you that we are performing a stress tests, and you could take a look that we've been handled for about a bit less than 1 million requests, less than 20 minutes. Let's take a look on the test results. What type of applications I've built? I've built a fast jar, Uber jar, Jeep with UBI8. It's a base image provided by the Quarkus, Jeep with distroless. And this is the point where the distroless is experimental. It's an experimental one on Quarkus, but I've decided we should to test it because we've prepared our previous solutions on the Spring Boot, and they were based on the distroless and on typical Docker. Okay, now we can take a look about what about the boot up. What about the boot up? It's for about 1 second, and about the Uber jar for about 2 seconds to boot up. And we'll compare with Spring results. If you remember these numbers, we can find this. Yep, Quarkus boot up time a bit less, and build time for about 4 and 8 seconds for GPUBI and distroless is for about 16 and 14 seconds, and for Docker solution 39. And the RPS in fast jar and Uber jar pretty similar, but in Docker solution we can find the degradation. And as I mentioned, and as I said before, we will take a look at it and we'll compare kind of pre-tuned solution and compare the with Docker based. I'm about the containers, and we'll take a look and compare with this one. Response time is about 13 or 14 seconds, and saturation point for about 2000. JVM heap a bit less than 1 gigabyte, and JVM non-heap pretty stable, 55. JVM CPU 9.5%, and thread max 25-23, and for the Docker a bit more 26. I'd like to say that it's pretty same. So, but the Postgres CPU on the fast unit are in average 99%, and for distroless and Docker solution a bit less. What about the Docker images, UBI and distroless experimental? You could take a look that the distroless total image size is 384 megabytes. And for distroless, it's about 249 megabytes. And as Dive said us, we have an image efficiency score for distroless, which is that is experimental one, for 100%, and the UBI is 97%. And the potential waste of 16 megabytes, I don't think that it could significantly improve our total image size, but it could be. Okay, what about the Quarkus Reactive as native? We will take a look on the basic configuration, test results, and pitfalls. They're pretty similar for the Spring Boot pitfalls and the Docker image analysis. And basic configuration, you can find here a lot of commented lines, and yep, it was kind of tricky to switch from the one approach to the other. I should comment one line and uncomment the other one to build it in using different approach. But you can compare all the results I provided you and choose the one most fitted for your business, and just set up it and remove all the commented lines for this. Of course, we could. I would like right now mention that we could have a compression, and the compression level up to 10. 10 is higher, and it's about the UPX. I've compressed, and was pretty. It was pretty fun situation because of compression completed successful's, but I was not able to find the compressed image, and but let's talk about it a bit later. Okay, the basic compression in my book stays the same, and Quarkus version is the same. But what about the pitfalls? As I mentioned before in my previous sessions, so the resting plate or web clients or Jackson annotations, serialization or CERD requires additional type hints. You can find it on my GitHub profile with the sources, how I solved this, and it will be removed after in the bug I've provided to you. And about the Kotlin coroutines are supported because require additional reflection entries due to how coroutines generates bytecode with an object return type, and sealed classes are not supported yet. Custom repository implementation of fragments need to be annotated. Component and doesn't support Hibernate types, and some status require special build configuration, and test results. Okay, what about the test results? As you remember, on the non-native approach, we have for about 800,000 requests, but right now we can we have a bit less in total, and the response time in total a bit less as well. It's for about 700 requests per second, and on the 95 percentile we can find 16 seconds to offer response time. And what about the test results and the approaches I've used and types? And native executable build time is about 3 minutes, and native executable UPX max. As I said, I have tried to compress it, and I've compressed it, but I spent a bit more time, pretty for about in 3 times or even a bit more seconds. But we can take a look that if I'll tune this approach, we'll have the artifact size of 15 megabytes. For the native executable, we had about 50 megabytes. But I've researched this solution, and it provides in different resources not such a good results as a native executable, but I would like to compare it by now a bit soon. So about the manual micro-based image, it's about 30 seconds, 300 seconds, sorry, and my manual minimal base image pretty same. Distance-based image 238 seconds. Artifact size, as you can see, distal is 72 megabytes. Minimal is about 150, and for about 80 megabytes for microbase image, and the native executable 15, as I said before. What about the boot up time? For native executable, we can find that it's about 200 milliseconds, and for our other images using micro and minimal and distillers, we can find about 30 milliseconds. Pretty good, awesome. And what about the RPS? RPS is about, as I mentioned ago, a minute ago, native executable 700 requests per second, and for micro minimal distillers image from the 448 megabytes up to 507 megabytes. Oh, sorry, megabytes. Yeah, my bad. Request per second. Okay, response time from the 60 seconds up to 35 seconds on minimal base image, and the RAM consumption for pretty similar, for about 650 megabytes. About the threads of the micro and minimal distillers were 8 threads max, and 15 for native executable, and for the GPU for native executable 99, and for Docker solutions 57, 69, and 45. Okay, what about the images? Let's compare manual micro base image, and micro base image, and manual distillers base image. The size of the micro base image is 79 megabytes, and it could be improved because of potential base space is about 200 kilobytes. And in distillers, we have 72 megabytes, and as Dive said, image efficiency score is 100%. Okay, let's compare the security and vulnerabilities of the images I've built. First example is about the I'll pause it. This result is about the Quarkus distillers, and this one about the minimal. So I have a video recording about it. You could compare what kind of vulnerabilities we have and severities we have. Two of them are medium, but for minimal reactive, from low up to high vulnerabilities. Okay, Docker performance problem. And, we'll take a look on the security, I/O environments in compared tuned approach. What about security? Docker uses one mechanism named seccomp, and the issue has not been fixed yet. And Podman and Kubernetes have no issue with it. So if we are going to check the performance running your CI/CD, you could be or not enable it. Up to you. Choose the best approach for your business. And to turn off it, you could run with security opt, seccomp, unconfined, and you will have a significant performance improvement because of, I believe, in different situations, you are comparing performance on your Docker-based images in Docker, in Docker's approach, and it could bring you not such relevant metrics. And what about the I/O environments? Regarding the volume, bind mounts have limited functionality compared to the volumes. And when you're using bind mount, a file directory on the host machine is mounted into a container. The file or directory is referenced by its absolute path on the host machine. By contrast, when you are using volume, a new directory is created within a Docker storage directory on the host machine, and Docker manages that directory's contents. And this is a sample with volumes data that they've attached and removed the copy and provided a security opt flag. So native distillers solution, as we haven't seen it already, total requests have been held for about 546,000, and the tuned native 584,000 of total requests, and we have a bit more RPS, a bit less response time, and higher saturation point. We have no difference in RAM consumption, but As we can see, we have CPU consumption a bit less, and threads max the same, and Postgres CPU the same. Let's compare this approach that Quarkus team provides us with the Spring. We will compare jar test results and compare native test results and in Docker. Okay, what about the build time? We can find here that we have Spring Reactive in Quarkus. It's about the jar building time, and Quarkus have the highest time of 8 seconds, and the minimal time of building is about the Spring Reactive. It's about 3 seconds. But what about the artifact size? Spring Web 50 megabytes and Spring Reactive 40 megabytes, and a bit less than 20 megabytes for Quarkus. And comparing jar test results for boot up time, we can find that Quarkus provides as Quarkus said on its documentation that Quarkus for faster boot time, and yep, boot time is pretty less, a bit less for the in-jar solutions, and we can find that Spring Web had the boot time in average for about 3 or 4 seconds, and Spring Reactive a bit less than 3 seconds, and Quarkus a bit less than 2 seconds. And what about the Spring Web, Spring Reactive, and Quarkus about the RAM consumption? Spring Reactive had the highest RAM consumption, and the minimal RAM consumption for Spring Web. Yep, the winner of this section, and the Quarkus in the middle for about 1,000 megabytes. And what about the CPU? Quarkus consumed in average for about 5%, and for Spring is going 11, and the Spring Reactive 8%. What about the RPS? And there is the winner is the Spring Reactive. It provides us for about 1,200 RPS, and the next on the second place is Quarkus with a bit less than 800 RPS, and Spring Web a bit less than 400 requests. And saturation point for sure, Spring Reactive has a significant winning position here, more than 4,000 of users, and the Quarkus is about a bit more than 2,000, and Spring Web for about between 1,000 and 2,000. Okay, let's compare native test results. And again, a build time in this time, the most significant time for building Spring Web native application, it's about 200 seconds, and the second place is going for Spring Reactive with a bit less than 200 milliseconds, and for about 180 milliseconds, sorry, for Quarkus. And artifact size, Quarkus provides us the artifact size for about 50 megabytes, and it's the first place and the winner of the section, and the second place for Spring Reactive, a bit less than 80, and the third place for Spring Web. What about the boot up time? Spring Reactive provides us the less boot up time for native solutions, so with the in average 100 milliseconds, and for about 200 milliseconds for Quarkus and 300 for Spring Web native solution, and RAM consumption in average for Spring Reactive in Quarkus for about 600 megabytes, and a bit less than 300 for Spring Web. Okay, so Spring Reactive consumed a bit more CPU in comparison with the Quarkus and Spring Web. And for about what about the RPS? Spring Reactive for about 900 of RPS, Quarkus 700 RPS on the second place, and the Spring Web with the 400 on the third place. and saturation point 3000 for the reactive approach of the Spring, and for Quarkus a bit more than 2000, and the Spring Web a bit less than 2. What about the jar in Docker test results? And the most efficient file size is going for a Quarkus with 250 megabytes, and Spring Reactive 270, and Spring Web 280. And what about the build time? Build time is pretty less in comparison with Spring Reactive, and Spring Web is going for a Quarkus, and there's a winner section with the almost 50 seconds, and 35 up to 40 seconds for Spring Reactive, and 45 for Spring Web jar in Docker solution. And what about the test results? Jar in Docker boot up, Quarkus is about 1 millisecond in average, and for about 4 milliseconds for a Quarkus, and Spring for about 5. Jar in Docker RAM consumption, Quarkus for about 950 megabytes, and a bit less than 900 for Spring Reactive, and a bit less for Spring Web. And what about the CPU? Spring Reactive consumed a bit more than the Spring Web and Quarkus. And RPS, jar in Docker solutions, pretty similar. It's up to from pretty similar for Spring Reactive and Quarkus. It's going on from the 525 up to 635. Pretty similar, 100 difference, not a pretty similar. And Spring Web for about 150 RPS, and saturation point for Spring Reactive more than 2000 and less than 1500 for a Quarkus, less 1000 for Spring Web. And native and Docker solution test results. This is the last one comparing, and here we can find that Quarkus has a pretty less build time is about 200 seconds, and 1200 seconds for Spring Reactive, and about 800 seconds for Spring Web. And Quarkus has a smallest artifact sizes, so with for about 70 megabytes, and Spring Reactive for about 100, and 140 for Spring Web. What about the boot up time? In average for Spring Web native in Docker solution, what was for about 1 millisecond, 1 second and bit more. And for Spring Reactive, Quarkus are pretty similar. And for a RAM consumption, you can find that Quarkus is and Reactive have for about 600 megabytes, and Spring Web less for about 300. And what about the CPU? We again can find that Spring Reactive consuming a bit more CPU in average in comparison with Spring Web and Quarkus. And what about the RPS? Spring Reactive again on the first place, Quarkus on the second, and Spring Reactive on the third place. And the same we can find about the saturation point. So let's get everything together about the Quarkus, and let's compare with the Reactive and Spring. A lot of different approaches out of the box. It's a plus. It's a plus for Quarkus, but some of these approaches don't work, and this is a minus. Artifact size are less than this created by Spring. Yep, we've compared it, and we can find that's true, and pretty good result, and a bit less build time for native solutions. Yep, and Quarkus said that they about the cloud and containerization, about the native. Sounds good, and we've checked it out that it works, and resource consumption is less. Awesome, but saturation point and RPS are less as well. So what to bring into production, up to you. But Quarkus provides native solutions and says that it's ready for production. but Spring Native is an experimental feature at the moment. But as I said on the very beginning of this presentation, that Spring is going to bring to the world the native approaches for cloud and container-based images into the world. What will be when this will be not an experimental one? We could check it one more time. But I believe it will be a significant improvement of the Spring family, and we are waiting for it. So thank you, and you can find following this QR code my sources of my research. In this research, you will find a bit more information regarding all the approaches, and it's a kind of a long read for you. You can find links for my GitHub, where I provide the sources of Quarkus solutions, and you can just fork it and play with it as well. So you can provide feedback on the platform. It could be very helpful for me and provide me clear vision in the next talks. The next talks is going to be on the 8th of December on Java On. We are welcome to see on it. But what about the next performance results, about the Micronaut, Vertex, and etc.? I'm going to present you in the next year, and I'm waiting for you. Thank you one more time. You can find me on LinkedIn, GitHub, and Instagram.
Thank you, Vadim. Do we have time for questions?
I believe we have a few minutes. Yep.
Okay. Please, colleagues, feel free to add questions in the chat, and I will read it. I have a couple of questions from my side.
Yeah.
So when we faced with a new project, we going to choose a set of technologies, we use a lot of attributes for make this choose. Where is the place of performance there? What do you think?
Actually, I didn't understand clearly your question. Could you please rephrase it?
So when we choose a set of technologies for new
Yeah.
project, we should have a full picture of all pros and cons of the technologies.
Okay.
How often you use performance as main attribute, main quality attribute for choose technology set?
In non-functional requirements, you can find a lot of different SLIs, different metrics that should be followed, and based on this, you can create the SLIs and the SLO setup, and after that, you can have the SLA, and in differentiation with the SLO and SLA, you can have an error budget. So if you in most of cases, you get faced with the performance because of when you could bring more RPS on the one instance and do not scale up it, you could save the money. And it's about the cost optimization as well. Resource consumptions, mostly if you are talking about the cloud, where as how much we used the resource, so much we are paying. And it's about it as well.
Okay, thank you for your answer. I have one more question. How often you make this analysis? So the question is, do we have any progress from version to version in different products regarding performance situation?
Thank you for your question. Actually, I've started it from the Spring Boot to 7, and we have not so significant improvements on it, just improvements of libraries, and it's a kind of minor and patching. It's about the minor fixes, minor features, and mostly about the documentation improvements. I could not provide you clear and honest information what results we had on Spring Boot 2.3, for instance, where some improvements, significant improvements had been brought by Spring family. But I think that I will answer your question the next year when I will complete all my journey, and I'll compare all the frameworks I'd like to compare regarding the GVM board, and then I will gather all the information for sure. At time I'm going to check it up on all approaches I've already did, and it could be in a half a year or even in a year. So I will bring you these results in a year.
Okay, and probably last one question from my side.
Okay.
When we use different technologies, frameworks on production, real usage and real character of usage of different products are different from testing environment. Do you have any results from real production environment? Probably do you use any tools for analyze real-time performance of application?
The real time, yeah, we can take a look on it. We can gather all the real time information provided in Grafana, and for sure, this is mandatory to have on the production lifetime metrics, and kind of setting alerts and following the best practices about the SRE, and if this question about it, yeah, for sure. And on my previous project, we've tuned it, and this is why I've started to do this performance analysis for different approaches, because of we had some performance problems on the my previous healthcare project.
Okay, thank you. I feel like you like measure and you like performance. It's really
Yeah,
really interesting.
saving time and saving money.
Yeah, thank you. I think that's it for today. If you have any questions, please feel free to write it in the comment under the video, and follow us on YouTube and in Telegram. Thank you, Vadim.
Thank you. See you later.
Bye.